Hey guys, welcome back to CloudRaga. So far we have gained some knowledge and now we know what is function interface and what is lambda expressions. Now let's write some code on it. So that will give us a basic idea how actually things works. So we are on blank project, it's just a core application we get earlier. Let's create one more project, Java project, and I'll call that Java 8. That's it. Next, next and finish. I don't need that, just don't create it. I don't want any module. It's a feature added in JDK 9, so that's fine. I just keep it simple, JRE 14 version and SRC blank. Okay, let's create one package here. So right click, new, and going to create a new package. Let's call this com.pack. Um, let's just call this lambda expression. In short, LE, lambda expression. You can call it anything, doesn't matter. Okay, so first thing is if you want to write lambda expression, the very first thing you need to create interface, a functional interface, right? So in this package I'll create a interface first, and let's just call this playable. Okay, that's interface name, playable. Okay, done. So interface is ready. And how do we know it's a function interface? I will mark it with at functional interface. Done. And you can see as soon as I mark this interface with this annotation, compiler starts giving me error. What it says, let's read this out. Invalid function interface annotation. Playable is not a function interface, or because it's empty. You have to give something. One abstract method that's required. So I'll say public void, let's just say play and semicolon. And as soon as you add one abstract method in there, a compiler removes that error. Okay, so that's one thing. What if I add more than one, abstract methods? Paste and play 2. Again, it starts giving error. What it says? Invalid at function interface annotation. Playable is not an interface anymore because you have added 2 abstract methods. So it's not required. If it is a function interface, you need to have only one abstract method. And okay, it's good. So what we have here? A play method, and now we can write lambda expression for which method? For this method. How? Let's see. So going to create a new Java class, and let's say cricket. Done. So it's a simple class, and class says implements playable. I bet implements playable. Okay, done. And as a core functionality, a class, if any class implements interface, so that class must give its implementation. So add unimplemented method. There we go. This is the normal way doing this, and here I say, let's just say sys out playing cricket, right? Okay, done. That's how we do this, right? And then I can create a tester for this. I'm just writing a normal class for now. So let's just say cricket tester. There's a typo. Tester. Okay. So for test classes, we have main method. Main method. Let's create instance of cricket. Cricket equals new cricket, and then I can say cricket dot play. And let's run this code. Run as application playing cricket. Okay, simple enough, nothing special about it. So what I just did, let me add this on paint to see all together what we have here. We have this interface ready, then its implementation inside this Java class, then we created its implementation. Nothing new, it's not a Java feature, it's just a regular Java Java feature where we are creating interface, giving its implementation and calling some method from there. Okay, what about this lambda expression, right? So where to write that? That's the question. So it goes inside our calling section. This remains fine, it's fine. I will do what? I will go back to this tester file here. Just right here after this calling play. Just giving some separators so we can see it's different code. Okay, done. So the method is play, and I have to write lambda expression for this method play, and you can see there is no parameter inside it, so it's blank. And we know how it works when we have a play blank argument. So just blank, then arrow operator, and what's its implementation? What it is returning? Nothing, it's void. So that means we can have any implementation. So if we go back to cricket class, we just printed this out, this, and copy it. I just copied this line, and with curly brace paste it, and what? It's done. Let's hold it here in some reference. So it goes to playable and done. Now we have to add some code inside it. Okay. Okay, not here. Okay, done. This is ready, and now what? Guess it. It's done. Playable dot play. So this is the lambda expression. We're storing that reference here and then calling play method. So it will act the way it worked. Playing cricket. Let's call this through lambda expression. Okay. So right click, run as application, and you guys can see it's coming from here. So this is its lambda expression. So what we just did, let's copy, paste on paint and compare the implementation. So implementation is right here. You can see it's left side and right side. What we did, we give the whole implementation class. Think, we are actually writing a whole class to give the implementation. But what I did on right side, just by using lambda expression, I reduced that one big thing. No more Java class, just one line which gives the implementation and we can call it. So you can say this statement and this statement are actually reduced to one statement. This one, this one. So they are doing some calling plus giving the implementation. So that's how you can write a lambda expression. So you can see how greatly we actually reduce our code. Instead of giving this line, I mean this class and then calling it, we just gave the lambda expression and then called the play method. So one big class is reduced to one lambda expression. So that's how powerful this lambda expression is. We will add some more code on it so we get some better understanding on it. So thanks for watching this video guys. Let's meet in the next video. Bye bye.